So this evening's lecture is on ATEX. It's a real point of expertise for myself personally, and also for the company, of course. Avonmore has been repairing ATEX actually since, I would say, the early 80s. The very first company I can remember we were doing ATEX for in a serious way was Merck Sharp and Dome down there in Clonmel, and they're still there, which is amazing, really. They're a long-standing company like ourselves. But anyway, we're at it a long time, and we have evolved, and like there is certainly every day is a learning day. And actually the lecture that I've put on this evening, it's actually a repeat of what I've done with you previously, but because it's so intensive and because there's such a lot of information in it, I think it actually warrants a repeat. Even if somebody has seen this before, I think you'll get value just as much the second time, because it's quite an intense subject. So what I'll do now is I'll start sharing the screen. So there you go. That's just a little bit about myself. John has already that done, so we won't dwell on that. I suppose other than that, if people are maybe not be aware, we're also in Dublin, but that's motor sales. That's ABB Motors Dublin. So another thing that I want to mention is an association which would be of very great use to anybody that's involved in maintenance. We're a member of it for a good while now. I'm actually, I would say, definitely involved in a big way since about 2010. But they're an American organization called EASA, EASA. It stands for Electrical Apparatus Service Association. So if nothing else, please look up their website, easa.com. What's on there is a whole lot of information regarding maintenance, but of course it's typically aimed towards electric motors, but there is many resources there available to non-members. But should, of course, you be interested in being a member, just give me a shout. I can certainly advise you anytime on that. But certainly look up that website. That's well worth looking at, easa.com. So on the subject matter this evening, electromechanical repairs to hazardous area equipment. An electric motor basically is a source of ignition. So effectively, an electric motor is actually, what I'm saying here is a bomb. Because I'm saying it's a bomb because all you need is those three elements. Oxygen, fuel is the hazardous atmosphere, and of course your motor. There are so many points in the motor connect as an ignition point. So the terminal block is the obvious one. You know, the bearings, if they fail, can be, of course, can be many hundreds of degrees. Can easily, you know, on an EX motor, they're typically rated T4 is the most common rating, which is 135 degrees. Now that's not really hot when you come to something like a bearing temperature. So effectively, when you have an ATEX motor, it's really effective to look at it as if that you actually have a bomb here. So in other words, if you don't have it correctly constructed and correctly applied, it effectively could be your bomb in a hazardous environment. So the other point that I really want to emphasize and what I need to get across here this evening is that us as the repairer are only one part of the equation. It's collective responsibility, and that's not just me saying it, it's the law states it. So equally, when and if there's an issue, the user, the installer, and the repairer are all equally looked at in terms of responsibility. So whether you had a hand in being the operator as the user, or the guy that actually installed it, you know, put on the cabling, put on the gland, lined it up, whatever it is, or me as the repairer, every one of us have to have responsibility. And the best way of covering your responsibility, which I'll be going into here, is basically having proper training. And more, I couldn't absolutely emphasizes more repair, or not repair, sorry, documents. Must record everything. So whatever you're doing, whether you're a user, an installer, or a repairer, whatever you do, record it, document it in detail. So the law states that if and when there is an issue in a hazardous environment and there is a prosecution, it only occurs when all reasonable steps are not taken. So single errors are not prosecutable. So a single error can be a human error, but there was a very large explosion in the 80s in the North Sea. It was Piper Alpha, probably people, again, all you need to do is Google it, but there was, I think, over 160 people died in that. There was billions worth of damage, but effectively anyway, when they investigated that, it wasn't one single error. It was a combination of several errors, whether it was the guy using it or the guy managing it or some guy forgetting to do this, that, or the other, or lack of process or lack of documentation. It ended up anyway, the two descriptions that were made, the two legal descriptions, I suppose you'd call it, that they were convicted on, and it was a conviction, was willful neglect and dereliction of duty. Now, they're legal terms, but they say an awful lot. As usual, legal language tends to be very accurate. So if you're found willfully neglectful, or you have a dereliction of your duty, you can be safely said you're in trouble. So responsible users must, and again, I'm stating when I say the law, I'm talking about the standards. The standards are 60079 is the series of standards for EX equipment. And you have various sections after that. And the repair one is -19, whereas the inspection is -14. So, but anyway, responsible user must verify the repair facility themselves or get an independent verification. That's part of the user responsibilities. Again, in recent times, you had an accident in England in a wastewater treatment plant. 4 workers were killed in that, and unfortunately, including a 16-year-old apprentice who can only have been a couple of weeks on the job. So that is what every one of us wants to avoid. But it happened, and that's in recent times. Whereas, we all hear about the Piper Alpha, but the likes of this, you may not. But it can happen, and it's up to us to ensure that we do everything in our power to ensure that it doesn't happen. So in Avonmore's case, and this is my own personal experience, it did happen to us, and it's a lot of the reason that we are in what we call an IEC EX facility now. As I said, we were repairing EX motors and EX pumps, although at that time EX pumps only probably came in maybe with ATEX was about 2004. But this particular item was an agitator, a submersible agitator, which we had repaired. It went into a wastewater treatment plant, into a tank in a pharmaceutical in Ireland, and I can't remember now, which was certainly only maybe a couple of months or something like that. Anyway, effectively we got that call that nobody wants to get it. To get that call to say that there had been an explosion, and they suspected that it was a mixture we had repaired, and they wanted us on site immediately. So anyway, the heel of the hunt, thanks be to God, the most important thing is that there was no fatalities or injuries. It blew a tank completely open, just pretty much like that picture you just saw a while ago. Insurance got involved, of course, and effectively anyway, we were being tasked for loss of production, which was round figures $1 million, disposal of the stuff that was in the tank, which was another $1 million, and then there was rebuilding of the tank, that was another $1 million. So in round figures, us as a company were being effectively sued, I suppose, for 3 million. So anyway, there was an investigation in, because of course our insurance got involved with the opposing insurance, and on it went. So I would say it took about 2 years, if not more, if not 3. And in the meantime, of course, there's a lot of uncertainty. But the contention by the pharmaceutical at the time was that we had fitted an incorrect cable on the submersible mixer. We had replaced the cable, yes. And it was a different color, which effectively the pharmaceutical would have thought that we had changed the actual specification on it. Turns out we hadn't, but anyway, that was their contention. And our contention at the time was that there was an incorrect installation. So what actually happened, and what in the detail of this, was on full investigation, it turns out that the operator, that was the operator within the pharmaceutical, had reset an existing fault condition that is specifically not permitted under the standard 60079-14. And as a result, the liability went 90% to the user, because he had expressly breached the standards. So effectively, in practice, what happened was it had tripped, but they reset on a trip fault at the time. So we ended up, our insurance ended up for 300,000 instead of 3 million. But the point is, anyway, it really opened my eyes to how vulnerable we were as a company, and we really went at intensely how we were going to protect ourselves in the future. So the learnings for us were, in practical terms, we had completed that repair following the correct procedures in a practical way, but our records were unable to substantiate our work. So in other words, we couldn't prove what we said we did. We couldn't prove it, no documents. We had insufficient traceability and calibration of tools. We had insufficient detail on our work report, and the competence of the individuals that did the repair were not verifiable. Now, we knew what we were doing in practical sense, but you can see all of those bullet points there. We had absolutely no way of proving it. It was just us, our word, if you like, versus theirs. So that's where we went wrong. The solution for us is that we needed to go from, effectively, we were ATEX compliant, which I would describe as ATEX aware, to an IECEX certified facility, which is a whole new level of approach. When you're doing a repair, it's I would describe the level of records as being forensic. So I'll show you examples of that now. This is the way we were. We would typically have those a whole lot of tick boxes with a whole lot of we call it prompts as to what should be. And you can see the vast majority of the first page is actually blank, and there's a couple of bullet points, if you like, on the second page, and yes, bearing sizes and lip seal sizes and mega readings, things like that. So be very handy for the technical guy that knows what he's at, but in terms of records, it's not what the paper is written at. So this was, again, we would issue typically that certificate there on the left-hand side, which said that we were meeting the BEMA EMT code of practice, which we were at the time. And the measurements are here, you know, on the flame pad. So that was pretty standard at the time. So anyway, if you look at the level of intensity and the level of forensic detail that now on that tick box structure, you can see absolutely every line is filled in, and not just tick box. There's a reason why we say the motor frame is in good condition, why the fan and clearance are acceptable, why the fan cover is in good condition, etc., etc. And you can see that we're using a lot more standards as well on top. You can see we're referring there to BS 6079-19, but also the ABP. In this case, this must be an ABB motor because we're using ABB repair manuals. We'll also physically locate all the entries, all the threaded entries that are on the frame of the motor will be physically located and identified on a drawing like this. And things like the type of bolt, you know, the type of lip seals, the material of lip seals, and, you know, good detail on the structure, the mechanical structure of the stator frame. Here we have, if you like, you could call it a composition, but this again is the level of detail. What's there is observations after dismantling it, then if there was further checks needed, and then a conclusion as to what was the cause of failure. In this case, it's actually a scheduled overhaul. And then a scope of work completed after. So again, you can see that the record taking here is intense. Here we have a sheet which itemizes the parts that we have replaced. So on the left-hand side is what we took off, and on the right-hand side is what we put back on. So in terms of a bolt, you can see that we have the thread size, we have the length of the bolt, we have the head type, you know, it's a socket head, it could be a hex head, and we have the tensile strength. So there's a full technical spec, if you like, on a bolt, both on what we take off and what we put back on. So in this case, we've put on, what I can see there is we've put on exactly the same as we've taken off. If you put on something different, it goes without saying it has to be better. Actually, you can see one there, fifth from the top. It says we have fitted tensile strength 12.9 instead of 8.8. So that's just an example that if we do change it, it has to be, it can't be weaker, it has to be stronger, it has to be better spec. Here are your measurements. Again, that's probably typical to what we did before. But our measurements of flame paths actually is what that is. So this is an EXD machine. Here then is a record of all the different tests that we do. You can see that there's possibly maybe 12 or 14 boxes there in the middle of that sheet. Not all of them are checked every time, but the applicable ones are. But the point is, this is a checklist, and behind every one of those tick boxes, there is a document. So truth be told, on any EX piece of equipment, we could end up with anything up to maybe 30, 40 records. People find that hard to believe, but we've been on the wrong side, and we don't want to be there again. So this is the way to protect yourself when you're dealing with ATEX equipment. The IECX certified facility scheme, I asked SGS BSIFA, who are the BSIFA are the notified body in the UK. So I asked them, you know, to summarize what the IEX service facility scheme was. So the last time I done this lecture must have been sometime around the spring of 2021. And Phil Oates sent me this, and he said at the time there was over 150 accredited workshops worldwide. Actually, I know from our association with ABB that anybody that's an ABB workshop, ABB are certainly pushing them in that direction at this point. 32 countries worldwide, they're the only internationally recognized third-party repair workshop scheme. So that's a fact. In other words, if you were, this is a worldwide scheme, by the way. It's if you're in America or if you're in Australia, this is IECX. So in other words, it'll cover UL, it'll cover PTB would be Germany, it'll cover, you know, Chassis or whatever it is in Italy, the different ones. But it is a third party repair workshop scheme, and it's the only one that I'm aware of. It ensures compliance with IECX standards of repair, and there's online assurance. So in other words, anybody can look up the IECX website, and I encourage you guys to do that. And you can view our certificate there, or anybody that's certified, that cert is up there. And of course, if you lose your cert for any reason, it won't be there. So in other words, it's just not me that's saying that I have the cert. It's important that it can be verified online with the IECX people. This is actually our cert. We're certified, the print is very small on this now, but we're certified for 3 types of EX. We're certified for flameproof D, increased safety E, and non-sparking N. And sorry, there's a 4th one there as well. We're certified for dust as well, which is T, EXT. So we're certified. It took us until 2013 to get certified. I'd say it took us a solid 18 months of preparation to get ourselves in shape in order to get it, but it changed completely the way we approached ATEX equipment to the better, for sure. So equipment users, if you're a user, accredited workshops are independently audited annual. This is comfort for the user. So yes, we get an audit annually. And we can be removed from the scheme if we're non-compliant. The workshop employees must reach a required level of competence. Now, competence needs to be explained. Competence is not just training. Competence is training with experience. So competence is something that we measure on a continuous basis. So for example, if somebody is doing EXD on a consistent basis, we'll consider them competent. But let's say if they didn't see an EXN machine for quite a while, maybe 6 months, 10 months, whatever it is, we will ensure that that person gets a refresher on training before they get back into EXN repair work again. Because standards can change, and we need to be aware, there needs to be a check all the time. So competence is training with experience. Facilities must be capable of handling the equipment they're accredited for. So as that's us with the 4 types of EX protection. Equipment must be fully calibrated and traceable. So that's all about your documentation. And repair reports must meet the required standards. And that's what I've demonstrated there while ago to you, is the forensic detail. And of course, that the customer is in possession of those repair reports. There is an increasing emphasis on safety and reliability, so it's essential that end users can rely on effective repairs carried out. That goes without saying. Safety is ultimate for everybody. This absolutely protects the safety of your personnel. Once it's a reassurance for everybody that it is as it should be. When the equipment is being used in potentially explosive atmospheres, the risks are greater, and therefore the emphasis on safety becomes paramount. Yes. So by entrusting, this is the most important paragraph really for me, by entrusting your repairs to an IECX accredited workshop, the end user can be confident that they have taken every effort to receive the highest quality service available. So it's trust, confidence. So to date, and it's still the same, we're the only IECX in this country. There are, I would say there are probably up to 20 in the UK. But we're certainly the only one in this country. That's worth shouting about, to be fair, because it's not easy to get. The 2 standards that anybody as a user should have are 60079-17, which is electrical installation, inspection and maintenance, and part 14, which is installation, design, selection and erection. Those 2 are your Bible basically for how you treat ATEX equipment on your site. So if I was to summarize user specifications, make sure that there's only competent personnel working on EX equipment. Competent is correctly trained, up-to-date trained, and experienced. You must keep detailed records of any work you complete, and I mean any work. If you open a terminal box on an EX motor, you must record that fact. Keep original documents on file for all EX equipment. we look for original documents as part of our repair procedure. And I can tell you 99 out of 100 people don't have it. But the law states you must have original documents for all your EX equipment. So you should have a register, if you like, of all your equipment with the documents behind them. And each and every case that you take on, ATEX inspections or ATEX procedures, you must have a responsible person to verify all work. I'll explain in detail what a responsible person is there in a minute. So to give an example of an inspection procedure, you need to go to and back actually the annex. There's several annexes in the back of the standard -14, and that will give you a checklist on the different inspections that you need to do. So they talk about 3 different types of inspections. There's close, visual, and detailed. So visual, for example, might be an annual, a close might be every 2 years, and detailed might be a full overhaul. Depending on your application. If it's a very, very, very clean application and you know maybe only works 2 hours a month or something, well then you can extend that. But if you do extend that period above 3 years, you need to record the fact, if you like, the risk assessment that you've done in order to extend that period. So for a responsible person, they shall be able to demonstrate, they shall be able to demonstrate their competency and enhance evidence, provide evidence of attaining the knowledge and skill requirements just required below. So that again will be under in either the -17 or indeed the -19. I won't read this out now because it's too texty, but the point is there's a very specific list of requirements there for being a responsible person. So the responsible person is typically the supervisory position, but must still have, if you look at D there, a working knowledge and understanding of relevant standards in EX protection and a practical understanding of EX protection principles and techniques. So as I said, typically the responsible person is in a supervisory role, whereas the operative must be equally understanding of those aspects of equipment design which affect the concept of protection and understand the content of certificates and relevant parts of the standard. That's very important there when it relates to certificates. On every EX piece of equipment, you have a certificate number. And typically, if you have the letter X after the number, it means there are special conditions on the use or the safe use of that particular piece of equipment. And it's up to the operator, in this case, or the operative, to go and find that certificate with those special conditions. A typical one that we come across is, for example, if there's a variable speed motor, they'll have specified there a maximum frequency, but they'll also have the temperature rating for that frequency. So they might allow you 140 degrees, for example, on a thermistor at T4, but at T5, they might allow you 160 degree thermistor. So the likes of those little details will be specified on the certificate, and it's very, very important. If there is an X after your certificate number on the motor, you need to see those conditions. So yeah, so basically that's the gist of the lecture. There's a lot of information there. I've probably gone through it a bit too quick, but please come back to me and we might answer some questions. Okay, thanks.
A lot of information to take in there, and it makes me glad to think I'm not looking after equipment like that any longer. So
yeah, I know. It's not getting easier.
Yeah. A few questions coming in there along the way. Regarding original documents, do quality scans of said documents hold up? Are the hard copies required for a certain length of time?
Scans are perfectly acceptable. Absolutely acceptable.
No.
And the main thing is that you have them and that you can lay your hands on them when you need them. So scans, no issues whatsoever.
Being able to find them is the key factor. Yeah.
Yes.
Is there any special electrical test equipment that you use that is specifically designed for EX motors?
The answer to that is only if you're actually using the test equipment in the EX area. If you're doing it on site, in other words, and you're inside in a live environment, no, your EX test equipment has to be EX rated, of course. But if you're in a safe area doing your whatever you're doing, you don't need any special equipment. But it's certainly you wouldn't, for example, take a mega into a hazardous area under no circumstances. Okay.
Okay. Has Brexit affected the way business is done or availability?
For Brexit has affected us in terms of we use quite a lot of we used to use quite a lot of English equipment suppliers or material suppliers, and we've each and every case we found them in Europe. You know, I'm saying each and every case. Probably not every case, because obviously maybe some cases are highly specialized, but we have certainly consciously tried to find alternatives because of just silly paperwork problems caused by Brexit, which caused delays.
Okay. After every maintenance work, how long is the testing and recalibration of the equipment prior to its approval for reuse?
Well, it depends on the criticalness of the equipment, but typically you won't get away with any more than 2 years. We would typically calibrate most stuff every 12 months. And for example, the likes of micrometers, which are in daily use, they're done every 6 months.
Oh.
So it depends on your criticalness, and it maybe depends on the frequency of use. Again, an auditor will engage with you on the frequency of calibration, so it can be extended if you have good reason.
Very good. You
Okay.
mentioned responsible person there, and you went into it in good detail. Is that responsible person within the factory that repairs the motor, or is it within the facility that's operating the motor?
It's effectively wherever there is work being carried out, John. So wherever, if there's any inspection, where we call it the integrity of the enclosure is being affected in some way. In other words, if you're cracking open bolts, or if you're physically opening anything, there has to be an RP, because you'll have an operator doing the work. He will do his records. This is the way it should be done. He will record whatever it is he's doing, but there has to be an RP then which is off the work that he has done. So it's, if you like, a peer-to-peer check. No one individual then is responsible. And that, by definition, is a safer environment, because you have two heads looking at this potential. You know, every time that you go after an EX piece of equipment, you must think that it's potentially an explosive environment. So therefore, you need to decrease that. And the standard here is telling you basically that you need 2 people at all times involved in each and every task. One is the RP and one is the operator. So the answer to your question is, wherever the work is carried out, there has to be operators and RPs.
Okay, another question is, right, in the working environment within on the operating plant, the disconnecting of motors and the reconnecting of motors require specialized training?
Absolutely, absolutely. I think the standard on site tends to be complex. So you'd need complex trained installers, basically electricians, I presume, fitting EX motors or EX whatever. And through that complex training, John, they will be made aware of the necessary, documentation and their own competence as well, of course. In other words, typically training occurs every 3 years. But of course, what can happen in any 3-year period is that the standards can change. And if and when the standards change, you must be trained immediately to the new standard. So, in recent times there, the Dash 19 was updated. So for example, we would have rejigged all our training once that standard was issued, we were obliged to get all our guys brought up to speed to the new standard immediately.
Coming directly from myself, as a general comment, would people be aware of this level of documentation standards required on most factories?
Absolutely. I think people are hugely unaware. And I think it's a massive, it only comes home to roost if and when there'll be, unfortunately, an explosion. And that's when it comes home to haunt. But I think there's a huge, it's getting better, by the way. It's certainly getting better. My experience would be that people are certainly cottoning onto it. It's good maintenance practice, full stop, to do what we're talking about anyway. So it's going to increase your reliability of your plant by doing these kind of practices. And they're standard practices, really, if you're in a reliability mindset. But to answer your question, I think the vast majority, and I'm talking 90% plus, are simply not aware.
Not a good place to be.
No, it's not.
Right, another question. What are your standard electrical tests after rewinds?
Well, on the winding itself, you'll do the standard phase to phase. You'll go phase to ground. They are both insulation resistant measurements. But we'll also do what we call a surge test, which is an AC voltage put in at twice the nameplate voltage plus 1,000. It's a stress test. So the standards actually call for that once you have a new winding in place or rewind. Now you wouldn't do that on an older winding. You do that on something that's completely new. So you'd only specify nameplate voltage, test that nameplate voltage on a winding that had some work done. But new rewind, certainly the standards will call for a stress test at a multiple of the nameplate voltage.
Okay, question here. Are Avonmore certified to work on equipment that is certified explosion proof for power and intrinsically safe for control circuit?
Not intrinsically safe, no. We have an awareness of that, but we're not now ECEX certified for it. So the answer to that is intrinsically safe is typically I think it'll be more switchgear related, and that's probably more on the route of the complex guys.
After maintenance, do you properly reintegrate to the control panel?
Again, I'll have to default to more expertise on that, because, as I say, my expertise lies with the machine as opposed to what it's connected to. So, and I'm sure there has to be a very, very strict procedure, a detailed procedure when you're reconnecting one of these pieces of kit as to how you do it. There must be, but I simply don't have experience in it, so I can't.
That's fair. That's fair enough.
Yeah.
Are there any specifics for dust environments to be aware of?
Dust. I suppose the most important thing about dust is that people are generally just not aware that it's static is the big one. So in other words, it's things like the fan on the motor won't be plastic, it'll be aluminium. So in a dust environment as well, it's very important, we'll say, to actually maintenance be more than important, John, because if you get dust to accumulate, it's highly dangerous. So your regular cleaning of an environment. If you have an ATEX environment with dust, I would say the most important thing you can do is try to keep the dust down, try to move it. And if it does accumulate, get rid of it. Because
Okay.
that's where the danger is.
All right. Thank you very much for that. I had one there. You mentioned there that the repairer must verify the repair facility, and you said, yeah, that there was a website that you can look at and you get a list of
Yes.
sites. But supposing someone is looking to, say, verify that Avonmore is a suitable repair facility for them, what kind of
Yes.
questions do they need to be asking?
Well, if the cert is there, the cert answers all questions, right? But the most important thing is, I couldn't emphasize this more. Show me the records. Show me the documents, right? Because the detail in the documents tells all. And the other key one would be calibration of equipment. Absolutely, like there was a time pre-ICEX, John, we had one set of tools calibrated for. It was like the good set of china in the front room,
Yeah.
right? It was bought out on special occasions, but with IECEX, I mean every tool in every toolbox is calibrated, and that's, as you well know, it costs a lot, but it also takes a lot of time and effort to maintain that. So we have effectively two sets of everything, because when one set is away, you have to be working. So we have. Yeah. If you like, there's always a set actively looking to be calibrated. So calibration records, they're two key things to be looking for in any facility, regardless of the search. Making sure those records are there.
All right. What's the best path to take if the original documentation is unavailable?
Well, what we can do in that case, if original, which is, by the way, the vast majority of people, this is what happens when we request it. We're duty bound to ask for it, to request it. If it's not available, we repair according to the standard, which is this -19 standard. If the original documents were available, we can repair according to those original documents, and we can certify it accordingly. So in other words, if it was a Crompton motor and you had the original documents with it, we can look at those documents and we can certify it per Crompton. Whereas if we don't have the original documents, we repair per the standard. So basically on the motor, you'll see there's a triangle, signifies that for the standard, and with an R in the middle. If it's with the what I call the OEM documents, that R will be surrounded by a square. That's how you actually know when you look at our tag, all right, or whoever is issuing the cert to you. They'll have a square around the repair, around the R, if it's OEM documents are used.
Very good.
Yeah.
Regarding the full load current of an ATEX motor, can the overload setting be slightly lower than the full load current?
The full load current is what it is. There is no change whatsoever electrically for ATEX full load one way or the other. If it says its full load is X, you can set it to X. You don't have to derate it. That's already done by the guy that designed the motor in the first place. No change.
Okay, then we've had a good selection of questions. I have one last one. Where would an engineer that's looking after such equipment look for training to make himself or herself aware of what's required?
If he looked up the website that I referred to actually at the very start, easa.com. The local one actually for me here would be EASA9.org. So EASA9.org. That's the European region EASA. So we do regular ATEX training. EASA is there, and there's another, the English Repair Association is the AEMT. So letter AEMT. I think there's .co.uk. They also do a lot of EX awareness and EX, machinery repair training. But as regards installation, I think O'Shea's in Cork have done it for many years. I think they run a complex course. So that's as far as I'm aware for training. Certainly in our view, we use both the AEMT and ESA for our training, for what we're at.
Okay then, very good.
Yeah.
I would like to thank you on behalf of the attendees and myself and Misha for what was a very interesting and I would imagine an eye-opening presentation for a lot of people. I'm going away from looking after it now, but as I say, I wouldn't like to be out there on the front line. And I suppose it's what's coming all the time. There's more documentation and more controls coming with everything. But certainly where there's such a high risk involved, you need to be getting it right 100% of the time. So many thanks for that.